Kasi pag hinintay pa natin sila, mauubos yung oras natin. So, let me share my PowerPoint on cooling towers. It's available sa Blackboard, ano? Okay. So our topic for today is cooling towers. Ano, generally, of course, from the term, this is generally used to cool water. So water is generally used in heat exchanger to cool products and raw materials. No? So sayang naman kasi after cooling, itatapon nyo na yung water kasi hot water na siya, no? So sayang naman. It's ano both in terms of economic kasi mahal ang tubig at saka in terms of probably environmental concern, ano? So it's much better to recycle the water. So that's why we have cooling towers. So basically, ipapump nyo lang siya sa taas ng cooling water and then pagbaksak niya sa baba, malamig na ulit yung tubig. Ganun lamang yung cooling towers, ano? So we're going to discuss yung mga concepts na involved sa calculation sa cooling towers, and then we're going to calculate some unit operation parameters, ano, like for example, gaano ba kadami yung makeup water na kailangan, kasi di ba paikot-ikot lang yun, pero there are some losses, so we're going to calculate the losses, tapos yung syempre yung losses na yun yung magiging makeup na ika-calculate natin. And then ano, magdi-design din tayo ng cooling tower. We will try to calculate the diameter of the cooling tower na required. Tapos meron kasi yung ano may fan siya sa taas, no? Kaya lumalamig yung tubig. We are using fan. So kailangan calculate din natin yung horsepower ng fan. Tapos we will try to calculate the height. Medyo mahaba nga lang yung derivation ng calculation ng height. So siguro nasa PowerPoint naman, kayo na lang yung magbasa, baka hindi natin matapos pag diniscuss ko natin yung tingnan natin yung oras, ano. Pero we're also going to try to calculate the height requirement for the cooling tower. Tapos yun. Probably that's it. Yun yung gagawin natin sa cooling tower. So, ganun pa rin, we're going to discuss the different types of cooling towers. Ano ba yung nasa loob ng cooling towers, bakit lumalamig yung tubig, no? Okay. So in an industrial process, hot water is generally generated. So if you use water to cool products and raw materials, you're going to generate hot water. Most of the time, it is more economical to cool the water than to dispose it, no? Alam niyo naman kung gaano nakamahal ang tubig ngayon, ano? Sa amin, mga 20 pesos na ata or 25 pesos na per cubic meter. Sa planta, generally, hindi naman sila bumibili sa, sa Laguna Waters, hindi sila ganun. They usually dig their own deep, ano yun? They get their water from the ground, you know? So, mas economical yon. Okay? So, cooling water is generally done through humidification by countercurrently mixing water with air. So as you can see from the figures in the side, we have different types of cooling towers. So generally it is spray on the top of the tower. Tapos on the top of the tower, this is the pan. No, you have a big pan. Sa MCL merong cooling tower. So generally pag nagdi-discuss kami ng cooling tower, pagkatapos naming ma-discuss yung concepts, no, yung mga design ng cooling towers, nagpo-field trip kami. Nandun lang naman sa may malapit sa likod ng basketball court. 'Di ba doon sa likod ng basketball court nandun yung ChemEng lab. You're familiar with that small building in the side of the basketball court? So sa likod noon may cooling tower. So pinupunta namin yung cooling tower doon, ano? Pang ano lang 'yun, pang laboratory lang. So part siya ng ChemEng lab. Okay, so yun, basically ang nangyayari lang dito, if you're going to take a look at this part, ini-spray lang sa taas yung water and then you have a pan, this one, parang electric pan. So the fan sucks the air, no? Ito may butas dito, may opening dito sa baba. So it sucks the air right here, tapos it flows countercurrently towards the water, no? So yun, yung basically kasi mainit yung tubig, you might be asking bakit mainit yung tubig? Kasi nga galing siya dun sa mga heat exchanger, ginagamit siya pang palamig ng mga products, ano? So mainit yung tubig and then pag binuguhan mo siya ng air, bababa yung temperature niya. So mamaya, basically ang concept dyan is, kasi mas mainit yung tubig, tapos malamig yung air. So that's one reason, sensible heat. Another reason is, pag yung water, it is acted upon by air, some portion of it will evaporate. So ang evaporation may cooling effect. You're familiar with that? Di ba? Pag naglagay kayo ng alcohol, o kaya binasa nyo yung kamay nyo, tapos nilagay nyo sa electric fan, para mag-evaporate yung alcohol o kaya yung water. Di ba? Pakiramdam nyo malamig. No? So ang evaporation ay merong cooling effect. Yan. Dalawa yun, latent heat at saka sensible heat yung nawawala sa water sa cooling towers. Okay. So this is the cooling tower peel. So sana kung nasa MCL makikita niyo yung actual na peel. So sinisilip lang namin sa ilalim yon, kita yung peel. Now this is a plastic material, So basically, pag in-spray dito yung tubig sa taas, makikita niyo naman yung tubig pag in-spray doon. In fact, hindi nga shower eh. Kung natatandaan ko, parang may tubo lamang doon. May tubo lang na nagdi-deliver ng tubig doon sa taas ng cooling tower sa MCL. Tapos, pagpatak niya dito, magdi-drip siya dito sa ilalim. So makikita niyo yung dripping dito sa ilalim, parang ulan. Actually, ulan na maliliit yung drops. So basically, this peel parang distributes the water, into drops. So basically, it increases the surface area of the water. So pag sinak yung air sa ilalim nito, it will have a larger area of contact with the air. Kaya bababa yung temperature ng water. No? So this is the cooling tower peel. This is made up of plastic. Mas ma-appreciate nyo actually kung nakita nyo yung operations sa MCL. Pero hopefully pag nag-lab na kayo, makita nyo. Sana ipa-operate sa inyo. Ang dali-dali lang naman niyang i-operate. Hindi ko kasi alam kung ino-operate pa rin yung laboratory. Matagal na kasi ako nakapagturo. Kasi pag medyo duduwag-duwag kasi yung nagtuturo ng lab, hindi ino-operate yung mga equipment kasi nakakatakot. Yung halimbawa, yung steam generator, syempre, steam. You're familiar with the steam, di ba? Parang yung sa, parang yung halimbawa, nagpapakulo kayo ng tubig. So, ganun yung generate ng steam generator. So, meron din tayong turbine. So, papasok siya sa turbine. Tapos, paglabas doon, may condenser din tayo. Papasok siya sa condenser. Tapos, ayun, may pump. May nagpa-pump, papasok, pabalik doon sa yung, di ba, condenser. Yung condenser, it uses cold water to condense the steam, the low pressure steam. So tumataas yung temperature doon sa condenser. So ang ginagawa, yung tubig doon sa condenser, pinapump doon sa taas ng cooling tower. Ganun yung operation nung laboratory natin. Din nga lang kasi pag medyo takot yung instructor, hindi ino-operate yung steam power plant. I don't know kung anong ginagawa nila sa laboratory, ba tayo nilang i-operate, Pero sana makabalik. Sana makabalik na tayo. Siguro tinitingnan lang nila yung equipment nila. Pero nung nagturo ako nito, ino-operate ko to. Ang dali-dali lang naman i-operate. Saka makikita mo talaga yung steam generator. Meron kasi siyang window. So makikita mo talaga parang may flamethrower sa loob. It's quite interesting, At saka ito, yung cooling tower. Pag kita nyo doon sa taas, binubuga lang ng tubo yung tubig, pero pagdating doon sa ilalim parang merong ng ulan. no? So it converts, it converts the water flow into somehow rain-like structure pagdating doon sa ilalim. It increases the area, the surface area of the water. Imagine nyo, so kaya dinadaldalan ko kayo para matingnan nyo ng matagal tong cooling tower kasi nga hindi nyo makikita ng actual. So hindi pa naman kayo siguro nagke-chem-eng lab. I hope na i-imagine nyo. This is plastic. Tapos yan, parang pag tinignan nyo actually parang parang merong mga labyrinth, no? Parang merong mga karton, merong mga rooms, ano? So, ganun yung design. Yan. So this is the first type of cooling tower. This is the induced drop. So pag sinabing induced drop, meron kayong fan sa taas, no? So this induce the drop. The drop means the air, no? The flowing air. Counterflow tower. So counter current yung flow, di ba? Yung water pababa, yung air pataas. So may fan kaya induced drop. Counterflow tower. So ito walang fill, ano? Yun yung difference ito with the other types. Wala tong fill. So yung susunod meron na siyang fill. So this is an induced drop counterflow tower with fill. Ito yung fill niya. Yung fill na to, yung kamukha ng plastic kanina. So again, the hot water is sprayed or introduced at the top. Tapos yung air, dito pumapasok yung air, sinasuction ng fan sa taas. So dito, meron ditong wire, so the wire catches some water, some water goes with the air. So para mabawasan natin yung losses, meron ditong parang wire mesh or whatever kind of contraption you have. Iba naman, pwedeng wire mesh, depende sa design ng cooling tower. Basically, this catches the water. Yung liquid na dala-dala ng air, Kasi pag hindi nyo kinontrol yun, pag sa industry, relatively malaking volume yung mawawala sa water. And we don't like that to happen. Sayang din. So meron tayo ditong parang pang-catch ng liquid water sa taas. So this is an induced drop kasi may pan pa rin siya, tower with fill. Ito yung plastic, And then we have an induced drop, double flow, cross flow tower. So may pan pa rin tayo kaya induced drop. Tapos we have two sets. Two sets of water distribution. And then we have two pieces of fill. So that's why this is a double flow cross flow tower. Induced drop double flow cross flow tower. So ito na yung pag malalaki na talaga yung capacity ng cooling tower. Like for example, pag pumupunta kayo ng power plants, malaki yung requirement nila. Kasi yung condenser, mataas yung duty nun, So hindi kaya pag mga single fill lang yung cooling tower. So we can use a double fill cooling tower. Mas malaki yung capacity nito. And then finally, we have an induced drop single flow cross flow tower. Parang hinati lamang yung double flow, sa side. Mas malakas yung pan nito, di ba? Na-imagine nyo naman, dito kumukuha ng air sa side, tapos ito yung fill, tapos dito ini-introduce yung water, yung direction hindi na siya counter current. As you can see, yung direction ng air papunta sa side, tapos yung water pababa. So cross flow na to. It's the same with the previous one kung hindi niyo na notice, Ito cross flow din siya. Hindi siya counter current. So yung dalawang last ay cross flow. So we have double flow cross flow tower. Actually all of them are induced drop, And then we have a single flow cross flow tower. Any questions so far? Okay, so those are the four types of cooling towers. The other name for this unit operation is humidification because you are humidifying the air. Kaya lang, ako mas gusto kong i-adapt yung cooling tower. Kasi hindi naman yung air yung product nyo. Although you're humidifying the air, pero hindi naman kasi yung air yung product. Ang product natin yung water. So, mas prepare ko yung name na cooling tower. Okay, so na-mention ko na to sa inyo, You might be asking, bakit bakit pag merong air at saka bakit kayang palamigin ng air ang hot water? Okay? So dalawa yung reason. When you mix cold air and hot water, the first reason is meron tinatawag na sensible heat. So di ba ang driving force ng heat transfer ay difference in temperature. No? So generally mas malamig yung air sa water kasi we're using hot water, we're cooling hot water. So that's the first reason, sensible heat, no? Meron talagang transfer ng sensible heat because of the difference in temperature. The second one is the latent heat. Kasi when you mix water and air, there's a certain portion of water that will evaporate. And evaporation will result to cooling. No? So, yun naman, ang driving force naman ng evaporation ay concentration. Mas mababa kasi yung concentration ng water sa air compared dun sa, syempre, dun sa liquid water. No? Yung kasing ginagamit nating air, hindi naman siya saturated with water. So meron pa ring amount ng water, liquid water na mag-evaporate. And evaporation results to cooling. Question? So we're going to learn the concept of humidity. Humidity. Kung tandaan nyo pa sa Chicalc, di ba yung humidity, yun yung kilogram water per kilogram dry air. So i-recall natin yun before we go to cooling tower calculations. Tsaka yung relative humidity. So relative humidity, di ba, yun yung pressure ng water divided by saturated pressure ng water. No? Times 100%. Okay? So we can, as you can see from this chart, we can use humidity as a measure of concentration. Kasi kilogram water per kilogram dry air. We can use humidity as measure of concentration to evaluate the mass transfer, the rate of mass transfer through evaporation. And then from that we can also evaluate the latent heat from evaporation rate. Yun namang sensible heat. So ano lang yun? Euler's law, di ba? Or Newton's law, ano ba yan? Newton's law lang yun. Newton's law lang. Okay? Question? Do you have any question? Basta ang essence lang nitong slide na to, dalawa yung reason kung bakit lumalamig yung tubig pag minix nyo sa air. Kasi mas malamig yung air, so kaya lalamig yung tubig when you mix them. And then the second reason, merong evaporation na nangyayari. Kasi hindi saturated yung air, so some portion of the liquid water will evaporate. Question? Let's proceed. Okay, so these are the equation that you need to recall. First is for humidity. So humidity is defined as kilogram of water per kilogram of dry air. So how do we calculate this? So if you still remember, this is just calculated as pH2O. This is the partial pressure of water divided by P. P is the total pressure minus pH2O. So times 18 divided by 29. Ano bang nito? Tandaan niyo pa ba? Ano bang justification nito? Basically, di ba yung pH2O divided by P minus pH2O. This is basically pH2O. Okay, sorry. This is basically pH2O divided by P dry air. Kasi 'di ba, we have air tapos may water 'yon. So pag binawas natin yung pH2O, yung matitira na lang doon yung oxygen at saka nitrogen practically. So that's dry air kasi wala siyang water, no? So ito yung ratio na to, itong pH2O divided by P minus pH2O. Tapos actually this is if you're going to assume na ideal gas yung system. This is just equal to number of moles of water divided by number of moles of dry air. Do you agree? Do you agree? Pag ideal gas, equal lang yung pH2O divided by P dry air sa number of moles of water divided by number of moles of dry air. Kasi di ba PB is equals to nRT. Yeah. no? So pag halimbawa, pag constant lang naman yung B, no? Constant lang naman yung volume, syempre R is constant, same temperature lang naman sila kasi isa lang yung lalagyan nila. All these other term will cancel out. So P is equals to N. No? So that's why PH2O divided by P dry air is equals to NH2O divided by N dry air. So pag minultiply nyo ito ng molar mass, di ba ang molar mass ng water is 18? No? Di ba ang molar mass, halimbawa, kilogram per kilogram mole. So pag magka-cancel itong kilogram mole, ang matitira na lang dyan, kilogram water. Ganun din sa baba, pag minultiply nyo ng 29, yung, this is the molar mass of air. So kilogram dry air naman to, per kilogram mole. Mawawala din yung kilogram mole ng ano. So ang magiging unit nito is kilogram water per kilogram dry air. Do you get the justification for this equation? Kailangan nyo yung justification or else you need to understand the justification or else makakalimutan nyo yan. Yung palagi yung ini-emphasize ko. No? Questions? Do you have any questions? Naintindihan ba? Kung bakit ganito yung formula natin ng humidity? You need to understand this. Or else mag-e-effort kayo mag-memorize yan. Pipikit kayo. No? Tapos, sasakit ang ulo nyo. Tapos, mamememorize nyo na. Kaya lang, pagkatapos ng exam, makakalimutan nyo na. Pag hindi nyo naintindihan. Ganun yung kwento nyo. Pag kumuha kayo ng board exam, di kayo na masyado nakapag-review, babaksak kayo. Sad. Kaya kailangan naiintindihan nyo yung justification. Questions? Okay, let's proceed. Saturation humidity, ano? So, hindi naman to ganun ka-importante. Na kay Gene Copies lang to. Limited lang kay Gene Copies. Pero basically, this is, ang definition nito is P star H2O divided by P minus P star H2O. Yung P star, that is the saturated vapor pressure of water, of pure water at that temperature. So basically, ito yung nakukuha sa steam table. No? Itong P star H2O. Halimbawa, given yung temperature. Halimbawa, temperature is 25 degrees Celsius. So, punta kayo ng steam table. Question? Punta kayo ng steam table, tapos hanapin niyo yung pressure doon. You're going to get the steam table. You're going to get the P star H2O from the steam table. No? Ito yon. Yung dalawa. So, times 18 divided by 29, you're going to get the saturation humidity. Do you have any question? Justification, kamukha lang naman yan, naging saturated lamang yung vapor pressure ng water. And then we have the percentage humidity, HP. So this is just 100% times yung actual humidity, H, divided by saturation humidity, HS. Okay? Percentage humidity. Pero actually, hindi yan yung commonly used. Ang pinaka mas commonly used is the percent relative humidity or RH. So ang definition ng RH is 100 times pH2O divided by P star H2O. Yung P star H2O is the saturated vapor pressure of water. And pH2O is the actual vapor pressure of water in the air. Do you have any questions? So kung nanonood kayo ng weather report, especially sa mga sa CNN, so mini-mention pa nila ang relative humidity. Sa Pilipinas ata, hindi trivia na yung mini-mention pag nagwe-weather report. Do you have any question regarding relative humidity? So sabi ko nga sa inyo, ito yung importante. Ito yung kailangan yung tandaan. No? Ito yung lumalabas palagi sa board exam. Okay, relative humidity is equals to pH2O divided by P star H2O times 100. Question? This is the definition, so I don't have to justify it. Pero nakikita nyo naman, di ba? Yung logic niya. I-divide nyo yung actual vapor pressure dun sa saturated pressure, then i-multiply nyo ng 100. That is our relative humidity. Okay, and also we're going to use the psychrometric chart, no? psychrometric chart or the Grosvenor chart. So, generally ginagamit ito pag merong given na wet bulb temperature. Ano nga ba yung wet bulb? Forward natin yung slide, ha? Ano ba yung wet bulb? Yung wet bulb, yun yung temperature pag saturated yung water. Hindi ko na matanda kung na-introduce ko sa inyo ang wet bulb at saka dry bulb nung check-out. Yan. Okay, so we have here two thermometers, no? So, yung simple thermometer will measure the dry bulb. Yung dry bulb is the actual temperature of air. Ano? Ganun yun. Ano? You have the airflow here, tapos meron kayong thermometer. So, the simple thermometer will measure the dry bulb or the actual temperature of air. Now, if we're going to place, halimbawa, wet cotton on the tip of the thermometer so that when air passes through this thermometer, it becomes saturated with water. So, ang tawag doon sa na-measure ng temperature ay the wet bulb temperature. So, hindi ko alam kung makaka-relate pa kayo. Siguro makaka-relate pa kayo. Basically, 'di ba, pag mainit, no? 'Di ba mainit yung hangin sa bahay. No? So, anong ginagawa nyo? 'Di ba maliligo kayo? So, generally yung water, mas mababa yung temperature niya kaysa sa air. Ganun yung So, the wet bulb temperature is generally lower than the air. Na-imagine ba to? The wet bulb temperature is the temperature of the saturated air. I mean, when you say saturated, it means it is saturated with water. No? Mas mababa yung temperature na. Okay? So, yun yung difference between dry bulb and wet bulb. Pag punong-puno ng tubig yung air, ang tawag doon is the wet bulb temperature. Let's return to sa ating Grosvenor chart. Nakagamit ba tayo ng Grosvenor chart nung sa checkout? Naabot natin Sa checkout na-introduce ko na sa inyo. You're familiar with the Grosvenor chart, with the psychrometric chart? Nakalimutan niyo na? Anyway, madali lang naman siya. So, ang sinasabi ko lang, pag merong wet bulb sa problem, wala kayong choice. Isa lang ang pwedeng solution. Gagamit kayo ng Grosvenor chart or ng psychrometric chart. No? In order to solve that problem. Pag merong wet bulb na given. So, paano ba ginagamit ang psychrometric chart? So, madali lang naman. Just locate the wet bulb temperature in this curve. Itong sa curve na to, nandito yung wet bulb. So, just locate this. Kung gusto niyo naman, dito niyo rin i-locate. Tapos, actually, kung ano yung katapat niyan dun sa taas, yan din yun. Just draw a line. Halimbawa, dito nakalagay 50. Pag nag-draw kayo ng vertical line from here, dire-diretso, so nakalagay din dito 50. Pero mas madali dito, basahin niyo na lang dito kung malinaw naman yung mapa niyo. Medyo maliit nga lang yung pagkakasulat. Mas malaki kasi dito sa baba. Pero ganun yun. Kung ano yung nakasulat dito, tapos you draw a straight line, din yun. That's the wet bulb. So first, locate the wet bulb. Tapos merong mga wet bulb lines. These are the wet bulb lines in the psychrometric chart. No? So tapos you locate the dry bulb. This is the dry bulb temperature. Ito, dry bulb temperature yan. No? This is the dry bulb temperature. This is the dry bulb, TD. So just locate this. Tapos you just draw a straight line, a straight vertical line, and then you locate the intersection of the wet bulb line and the dry bulb line. Tapos extend nyo dito sa side. Dito nakalagay yung humidity. Ito yung nakukuha sa psychrometric chart. No? So later pag nasa psychrometric chart na tayo, i-explain ko pa sa inyo, meron ding relative humidity lines, no? Ano pa bang meron dito? Meron ding dew point, no? Ito, dew point. So, yung dew point naman, you just draw a horizontal line from the dew point and then you're going to find the humidity. So, generally, we use the psychrometric chart to find the humidity, no? So, sabi ko nga sa inyo, pag given ay wet bulb, wala kayong ibang choice kundi gamitin ang psychrometric chart. Tandaan niyo yan, ha? And then, ganyan lang naman hanapin yung humidity. Let's proceed. We only have 5 more minutes. Simple lang naman yung mga problems dito. Sa umpisa. Huwag muna yung mga board exam problem. Doon muna tayo sa basic. Makikita nyo yung level ng board exam problem natin. Hindi siya ka-level ni Gene Coplis. Si Gene Coplis kasi basic lang yung mga problem niya eh. Nagka-calculate lang kayo based on the definition. So first, let's try to calculate humidity. Ano? This is example 9.3-1. The air in a room is 26.7 degrees Celsius, 80 degrees Fahrenheit, and a pressure of 101.325 kPa, and contains water vapor with a partial pressure of 2.76 kPa. Calculate the following. Letter A, humidity. So recall nyo lamang yung formula ng humidity. Di ba ang formula ng humidity ay 18/29 pH2O. Tandaan nyo to ha. P, this is the total pressure, minus pH2O. Tapos substitute nyo yung given. 18 divided by 29. pH2O is 2.76 kPa. Tapos the total pressure is 101.325 minus 2.76 kPa. So ilan yung H? Ilan yung humidity natin? Get your calculator. 3 minutes and 58. Ilan? Anyone? Yes, very good. Very good, Christiana. Very good, Jericho. Very good, Gio. 0.0174. Very good, Angela. No? 0.0174. Okay. So saturation humidity, HS, you need to use the steam table. So at this temperature, halimbawa 26.7, yan, 80 degrees Fahrenheit, ano? Gamit kayo ng ano. Kung minsan kailangan nyo mag-interpolate, marunong naman kayo mag-interpolate, ano? So pag tinignan nyo sa steam table, you're supposed to get P star H2O is 3.5 kPa. Raise ko na ano, dito tayo sa saturation humidity. So yung HS, if at this temperature, P star H2O, marunong naman kayong gumamit, ano? Tingnan nyo lang katapat. Pag hindi eksakto, sa saturated, ano, pag hindi eksakto, kasi temperature yung given, you need to interpolate. So 3.5 kPa. So HS, ang formula ng HS, 18/29, P star H2O, saturated, ano? P minus P star H2O. Ganun lang. Substitute nyo lang, 18/29, wala ko naka-red, 3.5, 101.325, minus 3.5. Last 2 minutes. Sige nga, 18 divided by 29 times 3.5 divided by 101.325 minus 3.5. I'm getting 0.022. Tama? Yan, very good, Gio. Very good, John Paolo. 0.022. Tatlong to ano? Yeah. Tapos yung percentage humidity, divide nyo lang doon sa kanina. 0.0174 divided by 0.022. And then yung importante, itong percentage relative humidity, yung RH. Ano? So to calculate RH, di ba ano lang to? pH2O divided by P star H2O times 100%. So basically, ano lang yan? pH2O natin is 2.76 divided by 3.5 times 100%. Ano? Ganun lamang yan. Ilan ang ano, percentage relative humidity? Mapuputol na tayo. Ano? So 2.76 divided by 3.5 tapos times 100, mga 78, ano? 79, 78.85%. Nakuha nyo, relative humidity. That's what is important. 2.76 and then just please connect sa another Zoom account. Zoom session, ano? Mapuputol na siya. Nakuha ba? Wala. Connect na lang ulit tayo. Discuss natin ito na maayos.